Hello, my name is Ssl and I'm the Principal Product Specialist at Twingate. Twingate is a remote access service that allows you to secure your cloud resources anywhere on the internet. Today, we're going to be doing a step-by-step tutorial on how to protect a Nextcloud virtual server running in the Hetzner cloud. Let's talk for a moment about why we need to do this. Well, when you deploy a cloud server, you tend to get a public IP, and you need that because you kind of want to access your resources when they're on the internet. The trouble is that resource can then be accessible by people you don't expect, for example, hackers. You can use firewalls to mitigate this, but it's difficult to figure out which sources you want to allow. You can also use VPNs, but they tend to be quite clunky and have a bad user experience. The problem gets worse if I add additional services. So here, if I have to protect a GitLab cloud server as well as my Nextcloud, I've got two public IP addresses to now think about and protect. So what are the objectives from today's video? Well, all your resources are going to be sitting inside a private network that is going to be hidden from the internet. That means you only need to pay for one IPv4 address, and you'll be able to manage access for your administrators and users from a web-based admin panel. And further, you can protect your users thanks to our new secure DNS functionality. Today's video is going to be in 5 steps. We're going to go over prerequisites, then we're going to set up Twingate, we'll set up our Nextcloud, we'll put a Ssl certificate on our Nextcloud, and finally we'll set up some firewall rules. Okay, so let's go over the prerequisites. First, I need a Hetzner Cloud account. I have that set up with a little project here. I'm going to need the Hetzner CLI tool that's called hcloud. Let me flip over to my console and I can do hcloud context active to make sure that's all configured. If you're not sure how to set this up, just look at the Hetzner installation instructions. I'm going to need a domain name. In my case, I have ssl.com, and I'm managing DNS via Cloudflare. It is not strictly necessary to manage DNS with Twingate, but we want an Ssl certificate today, and the easiest way to get one is using Let's Encrypt, and that requires some public DNS records to be set up. And lastly, I need a Twingate account. You can register one at twingate.com. My account name is Ssl. You can register anything you like. And you can see here in my account, I have my home network set up already. We're not going to be looking at that today. We'll be setting up a new account. So let's just set that up now. So I can say other and remote network Hetzner. Okay. So just so you know, we can deploy connectors via our web-based admin. So if you do have, for example, Linux VM already running, you can follow the instructions here and just copy and paste this command into your SSH. And lastly, I'll need the Twingate CLI tool. So you go to github.com/twinggatelabs/tg-cli, and in the releases tab, you'll see our CLI tool available for multiple different platforms. So I'm on a Mac, an x86 Mac, so I've downloaded this version here. And you can see it there. So what I'll do is I'll unzip it. And because I'm on an Apple, I just need to remove the quarantine attributes. And if I run it, I need to do chmod +x. Okay, perfect. So once this is set up, I can do, for example, tg resource list just to make sure that's working. The first time I run this, it will ask for some information about my Twingate account. So here I'm just going to type in Emerald, since that is the name, and I need to go get an API key. So I will go to my Twingate account. I will go to settings, API, and I'll generate a new token. I'll call this TGCLI. We will be deploying connectors today, so we will need read, write, and provision. I'll generate this token. Well, I just need to log in again. And here we go. I've got my token. So I copy that to my clipboard, and then I right click, paste it into here. And there we go. It asked me if I want to save my key, so I will actually say yes, just so that I'm not prompted. And you can see that the CLI tool is now set up. There's one more prerequisite that I almost forgot about. I need to go to the Hetzner control panel, go to networks, and create a new network. This is going to be the private network that will have my cloud apps inside of it. So I'll just call this private network. You can leave the IP range and CIDR as it is. I'm going to create this network in the EU Central region. If you are US based, you may want to use the US East option. So I'll create that network. Okay, so our prerequisites are now done. Okay, now the prerequisites are done. We can move to deploying the Twingate connector. So I'll just update our little diagram. It's tracking which step we're in. So back in my terminal, I can run tg again. We're looking at the deploy command now, and I'm just going to show you the help on this. So anywhere with any command in the tg CLI, you can add -- help, and you can see what the options are. So this tool deploys to a number of different clouds: AWS, Azure, GCP, Oracle Cloud, DigitalOcean, Hetzner, as well as local deployment if you want to do a customization or some on-prem work. But here we're going to do deploy Hetzner, and within Hetzner there's only one deployment type at the moment, that's the virtual machine. So I'm going to do tg deploy Hetzner VM. Okay, once I do that, the tool is going to talk to the Twingate system and give me a list of remote networks. I'm going to pick the Hetzner network. Shows me a list of connectors. Just a quick word on what these connectors do. If you deploy more than one connector into a remote network, it will automatically load balance and fail over. So for situations where you want to make sure that even if there's a software failure or a network failure of some kind, you can still get to your resources, it is highly recommended to deploy multiple connectors. I like the name of Ssl Cobra, so I'm going to select that one. The tool now actually talks to the Hetzner CLI hcloud and gives me a list of Hetzner regions I can deploy into. I'll pick Helsinki. I can choose which server type I'd like to deploy, so I'll choose shared. And it's worth pointing out that Twingate's connectors are fairly lightweight, so 1 CPU, 2 gigs of RAM at €2.99 is perfectly adequate. It's going to give me a list of all of the private networks in this project, and unless I want to deactivate them, I just need to click return. And finally, it's going to ask me if I want to set up an SSH key. So if there's already an SSH key in my Hetzner account, I could use it, but in this project I don't have one, so I'll just create a new one. I'll call it tg Ssl Cobra, and it's going to create the key locally, and it's going to upload it to Hetzner, or upload the public key. I can see that there. It will ask me if I want to enable the firewall. I think it's a good idea, so we'll say yes. and then it's going to start provisioning the virtual machine. If I go over to my servers, I should see it. Okay, so the machine will take a couple of minutes to come online. I can keep track of it, but this will be the proxy that will connect to my private network. It's worth pointing out that Twingate's connectors do not require any inbound internet access, can be completely firewalled off. They only require outbound access to the internet. What I'll do now is I'll click on the network tab in the Twingate control panel. I'll go to my Hetzner remote network. I'll go to the connector that I've just deployed, and I just need to wait for a couple of minutes for this connector to come online. Okay, the connector is now online, and I can see some metadata around where it's deployed, what the outbound IP is, etc. Okay, so it's got a public IP of this, and I can confirm that by looking in the Hetzner control panel. So let's go back to my terminal. The command completed and gave me some information that I may want to save, and it also tells me how I can now get access to this. So ordinarily you might try SSHing into the public IP address. So let's try that and see what happens. Unknown host. So the reason why SSH is not working over the public internet is because we've deactivated being able to directly connect to the SSH unless you are on Twingate. So this provides an additional level of security to prevent people trying to brute force their way in. I know that's going to be quite difficult with the public-private key pair that we've created, but it is still an attack vector that we have managed to eliminate. So the question is, how do I now get access to SSH on this virtual machine that I've created? Well, let's go look and set some access rules up in Twingate. So I'll go to the admin panel. What I'll do is I'll go to the team tab, and actually let's go to groups, and what I'm going to do is I'm going to create a group called Hetzner admins. What I'll do is I'll add myself to that group, and now basically if I'm in this group, the idea is that I'll be able to get SSH access. The way this is going to work is I'm going to go back to my network tab, define a resource for SSHing into the private network, and link my admin group to that resource. So I click on add resource in the Hetzner remote network. I'll switch to a CIDR resource and I'll call it okay. Here we can put in an individual IP address or a whole CIDR range. If you look back at our cloud and we look at networks, we can see that we have a private network range of 10.0.0.0/16, and actually I want my admins to have access to the entire subnet. So what I'll do is I'll add 10.0.0.0/16, and I won't add any protocol restrictions for this, and I'll click add resource. And here I get to choose which groups to link it to, so I will link it to the Hetzner admins group. So that access control is now set up. The next thing to do, which I've already done, but I'll show you what to do, go to twingate.com and you click download. You download the client for whichever operating system you're on. I'm on a Mac, so I've got it. It comes from the Mac App Store. So once you have that, Twingate will appear at the top and you can click login. It opens a web browser to authenticate me, and you can log in with any social provider. So if you have a Google account, Microsoft account, GitHub or LinkedIn, you can log in with any four of those. As long as the email matches what's in the Twingate account, it's going to work. We also do support identity providers like Azure AD, Okta, etc. But I'm just going to log in with my Google account. And once I'm authenticated, I get this green check. and I can close my browser, I see that the icon has bolded, and if I click on it, I can see my subnetwork resource. So now what I can do is go back to my terminal, sorry, and actually try copy paste this SSH command. Because I've been granted access to the entire subnet, I can actually refer to the Twingate resource by its private IP that's inside Hetzner. Okay, now I've SSH'd in. So we've secured our private network and we have secure access to the connector, and no one on the internet can get access to this unless they've been granted access to your Twingate account and to this resource within this account. So now the Twingate setup is done, we're ready to deploy Nextcloud. So let's go to the Hetzner Cloud Control Panel and go to Servers, and we'll add a server. I'll deploy this one in Helsinki as well, except here I'll choose Apps and Nextcloud. I'm going to use their recommended server size for Nextcloud, and the only thing I'm going to change is I'm going to remove the public IPv4 because we don't want it on the IPv4, and I'm going to select the private network. I'm going to leave IPv6 on for now. I am going to switch it off later. Technically this is not needed, but I mentioned earlier we need an Ssl certificate, and this is going to be the easiest way to get it. So I'll just leave that for now. And the only other thing here that I'm going to do is I'm going to use the SSH key, the same SSH key that was generated for my connector, but you can use a different one. If you want to create a new one, go ahead. And for the server name, I'll just call it Nextcloud. So I create this, and you can see it's given a IPv6 address. One of the reasons why we need this as well is because we need outbound internet access for this Nextcloud server to be able to update and get resources off the wider internet. Okay. So now this server's online, I can just copy the IP, the private IP that is, and what I'm going to do, I can go back to my terminal, I can exit the SSH to the connector that I was in, and I can SSH in to the Nextcloud server. This is going to work because if you recall, we set up access to the entire subnet within Twingate. So there we go. Now I'm in the Nextcloud configuration screen, and it's going to ask for my domain name. So there's a couple of things I'm going to need to do here. Let's call this nextcloud.emerald.com. It does need to exist, as this documentation note tells you. Before I continue, I just need to go set up the DNS. So if I go to my DNS control panel, again, you may not be using Cloudflare, whatever you're using, you just need to add a record. We're going to actually add one quad A record here, that's for the IPv6. And what we'll do is we'll copy the IPv6 address. And paste it. So nextcloud.emerald.com will point to this IPv6. I'm just going to switch off the Cloudflare proxy and save this record. While I'm here, I'm going to add the record for the private IP as well. I'll explain in a moment why I'm going to do this, but it's going to make it easy if I just do it while I'm here. Okay. So now this is done. The obvious glare here is that anyone with an IPv6 will be able to get to my server. I'm going to fix that in a little bit, but let's go get our SSL certificate. So we'll click return here, change the default username. I'll give it a different password. I think it's all correct. And here it's going to ask if we want Let's Encrypt to provide us the certificate. This is the reason why we need to allow the inbound access temporarily via the IPv6, just so we can produce the certificate. It's worth pointing out that this isn't the only way to get an SSL certificate, especially with Let's Encrypt. There is something called a DNS challenge. It just takes a few more steps to set up, so we're not doing that today. So I'm going to say yes. Pick my email address. We can see it's doing the HTTP 01 challenge. And the application is now ready. Okay, so we need a way to actually get to this application. And one of the other things we want to do is switch off the IPv6 access. So what I'm going to do now is I'm going to set up some firewall rules on my Nextcloud server just to stop things coming in that shouldn't be coming in. So I can restrict all inbound access to IPv4 only by just typing in Ufw allow proto TCP to 0.0.0.0/0. That's effectively masking any inbound connections to be IPv4. And of course, we only have a private IPv4 address on this machine, so anyone on the internet will no longer be able to access this server. What I'm going to do is now I'm going to do Ufw Enable. And that will now switch off any access to the internet, to this box from IPv6, and already there was no IPv4 inbound. We need to do a couple more things. The issue with Let's Encrypt is that every, I think, 90 days, it needs to renew the certificate. And even though this application is going to do it automatically, that renewal is not going to work because the IPv6 is currently blocked. So there is something called a renewal hook that allows us to temporarily open an inbound firewall rule for scenarios just as this, and then close it again once the certificate has renewed. So to do that, what we're going to do is we're going to go to etc let's encrypt renewal hooks pre for before the renewal happens, and we're going to create a new script. So I'm just going to use nano and we'll call it allow IPv6.sh. And I can paste this script that I've got prepared, and I need to make it executable. So chmod +x allow IPv6. So once again, the next time the renewal runs, this is going to open up IPv6 access on HTTP and HTTPS just for a few seconds to allow Let's Encrypt to validate the domain and the web server. And then we're going to add a post hook called deny IPv6.sh, and it's going to close that firewall rule back again. Okay, so it's a very simple script. Ufw deny Apache full, that's the configuration for the Apache on here, and we'll save this. And we have to remember chmod +x deny IPv6. So now we've done this, we've actually skipped a few steps. We've set up Nextcloud, we've obtained our SSL certificate, and we have set up the firewall rules to prevent anyone on the internet accessing any of these services. The one thing left to do, of course, is how do we actually get access to the Nextcloud? So to do that, we're going to go to the Twingate admin panel, and I'll add a new resource. and I'll call it Nextcloud. And for the DNS address, I'll put in nextcloud.emerald.com, and I will put a couple of protocol restrictions on here. So I'll restrict the TCP traffic to ports 80 and 443. Now this web server is set up to redirect any HTTP traffic from port 80, so this should all be quite simple. Wait, my session is timed out. Just log in again. There we go. Right, so here I'm going to allow everyone access to my Nextcloud on the web server port, whereas before I only wanted administrators to access the entire subnet. As soon as I do that, it takes a few seconds for the Twingate panel to update here, the Twingate client that is, and as soon as that update has happened, we'll find that we'll be able to access Nextcloud, hopefully. There we go, it's appeared. There's a couple of ways. I can just hover over this and click on open in browser. And here we are. I'm on Nextcloud and I should be able to log in. And there we are. Okay, so how do we know that this is actually working? Well, if I disconnect from Twingate and try to refresh this page, it will go nowhere and simply time out. So now I have a fully protected Nextcloud instance, and there is no way to access this unless someone who I have granted access logs in via the Twingate client, either on their mobile device or on their laptop. There's a couple of other things that we're going to set up. I mentioned at the beginning of this video that we want to protect our users as well, and a recent feature we added is called Secure DNS. So what this does is protect the DNS traffic. Oh, I've already got mine set up. I just need to click Enable, and this will protect all of my internet traffic, or DNS traffic, even if it's not Twingate traffic. And this provides an additional layer of security for our users, which is fantastic. The reason we need this as well is because Twingate is split tunnel by default. The advantage of that is as I disconnect and reconnect from Twingate, it doesn't interfere with my YouTube videos or my Zoom calls, but it only redirects the traffic that goes over Twingate. Anyway, I hope you found this video useful and you've been able to follow along. Any feedback is welcome. If you found this video useful, it would be great if you hit the like button, and thank you for watching.